Oh, good night, everyone, to another episode of Dan Does Data. Tonight, I don't know if you saw on Twitter, I'm going to be going on sabbatical for a while. I'll be packing up. I won't be doing the show for probably several months, at the very least, and I'll evaluate and see what's the best thing to do when I come back. So tonight, rather than going through every single project I've gone through, like the font recognition, the autonomous car, and the text generation, I just wanted to focus a little bit more on the autonomous car, since I think that's one of the signature projects I've had going here, and I've certainly enjoyed a lot of it, and that's the most applied project I've had. So on my GitHub page, dvubuntu/autonomous, I've got this, and this is also forked. Wow, forked 13 times, didn't realize that. There's Foobar Labs as the most recent copy as well. So this is going to be running on the car as it drives, I think this weekend or next weekend or one of those. And I just wanted to go and look at this a little bit more, make sure it's right, and just kind of walk through how does this even work. So I've got a whole ton of imports ready. I just started a new file. I decided was the easiest thing to do. But I'm going to be borrowing some from the previous model, just to see how things go, see if I can make this work. So let's just get this process on the road, shall we? Let me just grab some generic Python imports that I might need. I'm going to grab a whole bunch of Keras imports. I'm going to have to update these, actually. Let me update each one for Keras 2.0. I should have imported Keras first. Classic mistake. Classic mistake. Not importing Keras first. Lots of errors, but it's all actually fine. Everything's fine. We're all fine here. Let's import this model. That should be the same. Keras layers core. Let's see if this is the same. This 2.0 really threw me off. Yeah, and seeing all these errors is super irritating, but it seems to work, so I don't worry about it too much. Embedding, input, merge. I don't think we're actually going to need recurrent, but whatever. That's right, there's no more activity L2. Because now that's just an argument to your, when you say activation, you can give it regularization. 2 categorical, in case you need the back end, some scikit-learn metrics, some image manipulation, and some plotting. There we go. So let's steal some of my old code. And actually, I'm going to load in the data first, and then handle this other stuff. Here we go. Data. Oh, that's not what I wanted. So, nominally, these are random data files that are not the correct data files. Dan will no longer be doing data. Who will do data now? I don't know. Someone else will have to do data. There could be a Diane does data. There could be a Dimitri does data. I don't know. There's numerous possibilities. Anyone whose name starts with a D or a similar letter, I advise you step up to the plate and start doing data. So if we go to proj autonomous, we check out what's in the data directory. What's in the data directory that looks like a NumPy file. And you see these things. So there's yes, this is how big. 400 megabytes. Not so bad. Not so bad at all. Although that's stored somewhat compressed. That'll be like times 4. If I'm storing it in 4-byte objects. Sorry, if I'm storing it in like integers or single precision floats, which is not too bad. I can handle that. 1.6 gigs. Times 4, that's a little bit more than I want to deal with. When I load, can I say, give it a certain data type? You can't, can you? Let me see. npz load data type. And save z load, there we go. Fixed imports, encoding, mmap mode, no. Data type. Does it say type here? Curses. Well, I'll tell you what. Let's just try it. It shouldn't burn me. Let's see. Data slash images ARR2. See what happens. See if I get destroyed. If the stream goes down, you'll know what happened. Alright, that's not the end of the universe. What is images? D-type uint 8. Oh! I've actually... Okay, so that's totally fine. That's being stored. Very nice. Very nice. So these other ones... These other data files were originally from collection that I did, I guess, back in October. But I just want to start fresh, build a model, see where we end up. Speed, what does it look like? Now it's proj, whoa, not slash proj. Proj autonomous data, NPZ. What does it look like? Speed RR2, there we go. And this one will be data slash targets RRR2, almost certainly. RR2. Yeah. Okay. So close that. No such file directory. Data slash speeds. Plural. No. SpeedX. Ugh. Terrible naming convention on my part. My apologies, folks. Okay, so now we got our SpeedX, which is our speed and our acceleration. The magnitude, I should say, of those things. And targets is which direction we want to turn, and whether we're going forward or backwards, I believe. So if I just say plot.plot of, say, targets of all the rows, first column, for example. Yeah, so that's right. So you're going straight is 0.5. Turn left, turn right, turn left, turn right, so on and so forth. Which way are you actually going? I don't recall. Which one's which? Yeah, it doesn't really matter. I'm not too worried about that. Whereas I believe this data has us always going forward. Almost always going forward. That's curious. Oh no, this is forward, backward, forward, backward. Hang on. Hang on. What if I don't use lines? That's not helpful. And what is this then? What is... I no longer remember how I've structured this data, which is seriously going to impair my ability to model it. It can't be forward and backward. It's at the speed, maybe? It's got to be the speed. And the speed is either going forward or stopped. And there might be a small handful of the 2.0s that are reverse. That might be what it is. That would at least make a lot more sense. But let's actually look at one of these images. Images 0. So that's one of them. 64 by 64 images. I say plot.im show, it's not going to be in the correct order, right? Oh, not the shape. No. I got a new mouse this week. It's so good. It's very sensitive, but it actually works. Right, so you need to put the color channel, that 3 dimension, in the other slot. Transpose, it's going to be 1, 2, 0. Because I want whatever is in the first channel slot, which is the X dimension, to become first. The second channel slot, which is the Y dimension, to come second. And the color channel slot to be third. I'm missing one of these. There we go. Ding! Hey, what do you know? Familiar looking site, right? Driving down this road. And we can do this for arbitrary frames. For example, there's another car coming right at us. What should you do? Swerve left, I guess, here. Try to avoid this vehicle. That's what you should do. What actually happens, we'll get there when we get there, right? Does this new steer model show the picture? It'd be really good if it did. Let me snag this animation information. say go over data. So yeah, I'm putting the channel on hold for a while. I've covered a lot of projects that I really wanted to cover. I've gotten some other work that I went along with it that I really enjoyed. But as I found myself just doing the line-by-line videos for a couple weeks, I just thought, this is maybe helpful, but it's not as fun for me. I don't feel like I'm learning as much just going through all of it. It's learning a few new things, but not quite the same. Okay, this is the animation business. But this is going to involve using the prediction. So I'll just cut out that part. That should be fine then. And I don't want to save it. Shoot. Animate.show? There we go. I might try that again, but let's see. Comment that out, yada, 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 yada. Interval, next frame, that all looks good to me. Should be using images somewhere. Using val index, which was an old piece of junk I had at one point. Just start at 0, that's fine. Where is images? Images is down at the bottom. Figure, next frame, frames equals, what is next frame? Next frame is the function. One of these days I'll remember this stuff. Okay, I think this is ready to go. So we're going to show what the car should actually be doing. You know what? I don't want to do that. That's not what I want. I just want to highlight all this stuff. There we go. Get point is not defined. I thought I just defined that. I thought I literally just did that. I thought that was this. What went wrong here? Didn't have auto editing that turned on. Every time. I really should just turn that off. But when I'm running manually, I do want it. So it's a catch-22. Scale target steer not found. What is scale target steer? We're going to find out here. Targets. Okay. I think that's vaguely correct. Okay. One more time. This trial and error business. There we go. So this is suggesting always turn left? How can this possibly be correct? Is this lined up correctly? I don't know if these two things are correct. Targets of everything, comma 0. How about not everything? Show me the first 10. Those are almost all 0.5. Get point. If it's 0.5 is the point. 0.47. Yeah, what's going on here? T comma T. This is drawing a line. Oh, I'm doing this wacky scaling business. Oh boy, oh boy, oh boy. So scale target steer of 0. 1, 2, I mean those are all almost nothing. How did I come? Those targets must be different than the targets I'm expecting. Those look like, these look like targets that come from the Arduino, which are in this really funny format. They're in this super strange thing where you get this number between like 1400 and 2400 or something. And 1.0 must be totally to the right, and that's like 800. Right, so I don't really want to do that. So what I want to do is just say you happen to equal targets of everything, 0. That's how that's gonna play out now. Let's try that now. Hey, that looks a little more reasonable, right? Make that bigger for everybody. You know, you kind of go left, you dash right a little bit, nudge, nudge, listing slightly left, little left, stop. Gonna want to go left here. Right, this makes sense. This is what that's what your car wants to do anyway. I'm gonna keep these other lines around because we're gonna want those. Actually, I don't want that. We will want those once we actually get around to doing some predictions. So, let me just drag that down there. That's fine. Okay, making a model. So, this file includes I'm going to use the word simple in a very loose sense here, model. It tries to use the speed information as well to compute the steering. But I think right now I just want to make something stupid simple. I don't have good speed information anyway. We've got a little accelerometer on the car that we're trying to use, but that doesn't actually work all that well. So, you know what? I'll just make a new simple model. We'll just model equals sequential. We'll just initialize something new. That'll save me some amount of headache. I'll say model.add. I think it's conv2d these days. And how many kernels do you want initially? Well, what did I start with over here? 24, really. I thought for sure I would have more. Okay, let's do 24. And then I think you can... Now it's like this, right? To say to specify the window size. I didn't import conv2d, I did convolution2d. Let's do that. Conv2d. There we go. Kernel size, strides, padding, yada yada yada. Padding equals, no, padding equals same is what I want for this. Equals same. Let's see, kernel initializer, bias initializer, kernel regularizer, yeah. Regularizer. Especially hard to spell across the border like that. Add a little bit of regularization. Let's kernel. I really want activity. Doesn't really matter, does it? I guess not. Activation equals, let's do relu. We were using this ELU thing here. But I'll keep it simple. Do that. And there's no... Dropout isn't built in, which is unfortunate. Neither is max pooling. That's okay. We'll say model.add max pooling 2D. And I think that's just pool size, but it's not called pool size anymore. I thought it was called something different now. Nope, it's called pool size still. Pool size. I thought it was just called size. Like, that's what I thought it was. We'll see if he yells at me. 2, 2. I think that's all I'm gonna want right there. Alright, so let's just, for the sake of argument, build a stupid model. Right, model.add. Let's flatten this out then, after doing all that stuff. And then make a dense layer of trying to predict one thing, that being the steering. We're going to say activation equals linear. And then we'll just know that we want to actually convert that linear into a 0 to 1 kind of scale when we get to that point. I should say, when we get to that point. Yeah. Let's grab Atom Optimizer here. What are the options here? That's a default learning rate, so that's fine. Okay. And then we say model.compile loss equals mean squared error. Right, because we're predicting between 0 and 1, some decimal number, not a category. Optimizer equals Atom. And metrics equals accuracy. Can we even? No, that's not a metric that makes any sense. No, that's fine. Don't need any metrics, it turns out. All right, so this is a stupid simple model. What have I had as the model so far? Actually, nothing. Perfect. Input shape, right? Simple things here. So input shape equals, now the question is, what's coming first? The channel should be 3, 64, 64. Maybe? See what happens. That really shouldn't take that long to run. I don't know why it's taking so long. There we go. Well, that makes sense. Now we'll have 24 outputs, followed by still a size of 64 by 64, because of our max, right, because we haven't added the max pooling, and we said padding equals same, right here. Padding equals same. So even when our window, this 5 by 5 window, goes over the edge of our image, that's okay. We'll just sort of pad with nulls. Let's add one of those, add one of these, add one of these. Do this thing, do this thing. Now you have a dandy little model with 26,000 parameters. Yeesh. Okay. I feel like a sneeze coming out, but I can't quite. It's not quite coming out yet. Oh boy. Just for the sake of argument. Model.fit. We only need to do this. Batch size, number epic. I just want to say like 10 for the moment now. Shuffle equals true. Yes, that is true. Okay. So let's just see what this does. It'll take a little bit of time. Right, it's no longer NB epic, now it's epics. One of those things. There we go. It will take its good sweet time to compile, during which time I will muck around with the model itself, as is what I tend to do. So we can add another convolutional layer. This one, actually I want to have fewer filters as I'm going down. But I don't need the input shape business anymore, because Keras already will compute that for me. Yeah. Let's do this. 16 again, sure, that sounds good. And all this baloney. And then we'll also add model.add. Dense, so that's consuming a lot of my computational power, I can tell. Compute 64 numbers at that point. Activation equal, whoa. Wow, that is a more serious slowdown than I'm used to. We'll still say kernel regularizer equals L2 as usual. Yeah. There we go. So that should be all hunky-dory right there. This model will take a little bit of time to compute. I just want to get it somewhere doing something. Probably let it complete like a single epic, maybe. Just to get through, I think a loss of like Point oh 0.01, yeah, 0.01 would be good, I think. Because then on average, you're off by about 0.1, because it's the mean squared error. I believe that's correct anyway. That should be what I'm looking for. So this loss has a long way to go, my friend. And this is with a relatively simple model. Although it's got, there's 26,000 parameters here. And I've only got 32,000 data points. So, in theory, I got enough data to fit all these parameters, but it might behoove us to do more computation to have fewer parameters. Yeah. Oh, wow, that loss. Validation loss, 1.9. Why is that's so strange. Is there something about the last tenth of the data set that's much, much better? That's so weird. Okay, let me steal some more of this data set. Oh man. I had no idea this would be so slow. Alright, maybe I knew that, but... Okay. And we'll make some predictions. Wow. That is incredible. Absolutely incredible. Model.predict. There we go. And I can just say steer grids. There we go. Very nice. Very nice. So right, if the loss is on average 1.4, that suggests that if the mean squared error is that, take the square root of that to figure out how far off it is on average. So if it's on average, like 1 off, that's really bad. That's real bad. Now it might be that we're way too large, and so I don't actually care, because I'm going to end up, if the model is predicting a value of 2, but I clamp all the values 1 and greater, maybe I don't care. But I'd like the model to be punished for that and dial it back down. So that's why I haven't clamped that. Whereas I don't want to clamp it with a function like a sigmoid that's going to keep it from ever reaching 1.0. If I want to sometimes turn all the way to the right, and other times turn all the way to the left. Wow, that's getting surprisingly better. That's blowing my mind. Especially this loss from the first. I guess maybe it's accumulative over the entire data set. So it runs whatever the current model is on the current data set. Did I set my batch size here? I think it did. Batch size 32. That's fine. Also, 2 minutes per epoch. That's not too bad. I mean, that's a simple model, but that's the nature of the beast, I suppose. Anyway. So this uses scale steer spreads. Scale steer. Yeah, we are not doing that. I'm not going to plot that like that. That's just insane. No. Those are silly. Here's what we're going to do. Not scaling this. Just using that. No, whatever. That one I've already said. I don't really care. Okay. So soon we'll be able to make reasonable-ish predictions. I will let it complete this epic, having done 6 minutes of training live while I'm streaming here in order to get its answer. And I apologize for any flickering going on in the background as this takes over my graphics program, my graphics card, that is to say. That's just part of the nature of the beast, of doing this kind of computation. But you can tell it's getting better, right? If the mean squared error is 0.7, then the typical error is the square root of that, which is, I don't know, 0.9 or 0.85 or whatever, which is still really, really terrible, right? But that's definitively getting better. I'm amazed it's getting that much better at all, actually. So if you make the predictions for everything, and you come down here and I should really like do like the last tenth or something of the predictions. Validation index equals length of images divided by 10. Right, length of images minus length of images over 10. And I should just use this. Put this over here. So I only want to, that's taking too long, I don't have the patience for that. I only want to do the last umpteen of these guys. Val index to the end. Right? Because now val index is 32,000 whatever, and length images is, yeah, so we're doing like the last 4,000. So that'll save us some headache. There we go. Much better. So now we should see both our prediction and what the model is. Right, so you see the model is like crazy. It's all the way left, it's all the way right, and we're stuck behind this stupid boat in this validation set. This is absolutely terrible, having to drive behind a boat. You get really frustrated, you know, you're trying to get around it, left or right. The model is more or less kind of random right now, you can tell though. It's got a lot to learn. If it just went forward the whole time, it would probably be a lot better. But it's got a lot to learn. What happens if we adopt this much more complicated model? Let's see what happens, shall we? Also, I'm curious about changing the activation here. What are my activation options? Does it say activation? See activations on the Keras documentation, which I have open. Hooray! Activations. I don't want. I guess that's a core layer. Activation. Activation. What are the options? Nope, you didn't tell me. See activations. There we go. Take me there. Softmax. No, that's not what we want. ELU. No, no. Soft plus. Yeah, this is not a helpful thing. Telling me what these are, that would be really helpful. All right. Advanced activations. Leaky ReLU, pre-LU, ELU. Okay. None of what. I'm going to stick with linear. Linear I can definitely understand and do correctly. Alright, so let's see how this goes then. Let's see what this fitting process is. It took 2 minutes per epic before. And in, what, 3 or 4 epics, got down to mean squared error of, what, 0.7, 0.5? So now it's going to take 10 minutes per epic. But this loss is crashing down. It seems to be learning a lot faster, frankly, which is actually good, really good to see. Because I definitely do not have the patience to wait around for 10 minutes on stream while this thing tries to train. I might have the patience to just, I'm not sure what now. Yeah, to try something else, but not to wait for this. So I'll let that wander. But we're still just trying wacky different ideas. Wait a minute. This is, yeah, 10 minutes. Took 120 seconds before. Now it's taking, no, 300 seconds. 5 minutes. 5 minutes. Oh, well, 5 minutes. Clearly we have the time for 5 minutes. So it takes 2.5 times as long. But if it's willing to do much better, and I mean, this is a much more complex model, but in a way, it's not going to be as bad. In fact, let me just interrupt this real quick. We take a look at model.summary. It's got 40,000 parameters. So, you know, that's not surprising that it takes longer to train. But those are spread out among more layers. And in fact, this final layer is where most of that takes place. In fact, I don't think we need that many. I want to cut that number down quite a bit. That'll bring us down to 32,000. And this one, in fact, I only want 8. So that'll save me a couple of factors. So now let's train. Let's see. It came crashing down in about 80 seconds, we got down to a pretty low loss. This is doing about as simple, about as well. In fact, right, so now, model summary, now we're at about 25,000 parameters. So about as many as our first model, the like brain dead simple model. But now, doing much better. And you'll note again, the loss says, oh, now it starts at 0.5 because I let it train for just a little bit of time. And this loss is cumulative. I'm almost certain this is cumulative loss within the epoch. So it evaluates a current data point, the current batch that it's looking at, says, all right, how close am I? Add that to my loss and keep going. So that's why when you see the new epoch, oh, it's doing very well. And when you see the validation, this is why sometimes it can seem like you're doing really well. But you can see already, having looked at, I don't know, 4,000 plus a handful of seconds of other guys, we're now reaching losses of 0.2 something. And we'll check on the validation set to see how well we're actually doing. But a mean squared error of 0.2 suggests that we're typically off by about 0.4, which is bad, really bad, but a noted improvement over being off by a bajillion. Now this might mean that the model is almost always saying, go straight, go straight, go straight, because that's what you do 90% of the time. You just go mostly straight. So we'll see what it ends up actually computing here. And again, I haven't really done anything new in this model. I've just swapped around a few parameters. If I really wanted to try something new, I would probably say, oh, what about batch normalization? So after every layer, you've got a whole bunch of different values on different scales. Force them all back into be 0 to 1, essentially, is what I believe what that does. And that's batch normalization. Normalize the activations of the previous layer at each batch. Yeah. So that might be an interesting thing to try. In fact, layers, normalization layers. Let's try that. From keras.layers.normalization import improt. It's called batch normalization. Is that the only kind of normalization? That is the only kind of normalization available. Okay, batch normalization. There we go. Doink. So, if we added one of those after every one of our pooling layers, if we said model.add batch normalization, are any of these arguments required? No, they all have default values. Axis that should be normalized. Typically the features axis, yes. For instance, after con2d layer with data format equals channels first, that is what I have, set axis equals 1. Oh, okay, well that's really helpful. That's exactly my problem. Doink. I don't know what -1 means. Yeah, maybe that means it tries to interpret it. Not worried about this momentum, other stuff. True, add offset to beta, not worried about it. So if I do this after every one of these steps, here, this one I shouldn't have anything, I don't think. Maybe this will lead to an even better model, so to speak. Because now the input of every layer gets to deal with values between 0 and 1, rather than having to handle a wild scale. In a linear world, this doesn't matter, because you can just scale your parameters hunky-dory and it's fine. But I suppose in a world where you're applying regularization, you're penalizing these large parameters even though they're dealing with inputs that are scaled in funny ways. So I don't think this is going to be perfect, but it should be fine. And of course, if I wanted more information, Keras is super good. It keeps its references right here. I can read this paper, which I'm not going to do on stream, but it's something interesting that you can look at. And it's about 2 years old. Training by reducing internal covariate shift. Yes. So I'm going to let this finish its single epoch, about 5 minutes of training, you see that its error is much better than we got before. That it's now, what, like, what's the square root of 0.14? Is it 14, 144, like 1.2? No, that's wrong. Hang on. Square root 0.14. Yeah, so we're off by about 37. Not so bad, not terrible, in fact. And so let's take a look at the animation again. That being sort of the only way to really see what's going on. And now the model's actually, the red being the model, it's starting to track what we really want to do. And again, we've got this boat in front of us. This is horrible to deal with, but you're going to have vehicles in front of you as you go along. So it's not perfect. It's still wavering a little bit. Like we want to list left here and it's saying go right. But it's in the right neighborhood. It's no longer always jammed to the left, always jammed to the right. And importantly, the model is still doing something. And most of the time it's saying, go mostly straight. Go straight one way or another. So that's not crazy for a model. And it might just mean, well, let it train for a while. But here, we're going to be wild. We're going to add this. I don't want to add just everything yet. We're going to add batch normalization. Let's see if this is correct in what I want. Helps if I import that layer, doesn't it? Doink. Here we go. Now we say model.summary. There should be no parameters involved with this layer. There are. Interesting. Okay. Maybe I misunderstood. Normalize the activation previously already fast. Applies transformation that maintains the mean activation close to 0. And the oh, okay. So there's some parameters to figure out to make sure that you do that correctly. Okay. So there's like a little targets in the middle of when you're training it. It says, try to make the minimum 0 and the maximum 1. Alright, well, let's see how this goes. So now we've got a few more parameters, but hopefully it's not too bad. No, just a few more at each step. I guess 4 parameters per guy is standard. Oh well. We will get a rolling rate, we'll compile, and we'll say, hey, start training. And we'll see how this goes. And probably this is just going to be a matter of devising a model that seems reasonable and letting it train for a while. And there's almost certainly a family of models that would all perform pretty well, and any one of them would give me reasonable-ish results if I let it train sufficiently long. But hopefully not too long, and that's why I have this validation data. One debate I saw on the internet the other day was when you're doing these convolutional layers, whether you should do the activation first and then do the max pooling, or the other way around. And I'm of the opinion that it doesn't actually matter, provided your activation is monotonic. For like monotonic increasing, I should say. For example, if it's linear or whatever, if it's linear, then whatever was the maximum before will still be the maximum. And so who cares? Right? So you might as well do it afterwards, because that will save you a little bit of computation. In this case, I'm actually doing it before just because it's more convenient from a programming perspective, and I don't think I'll save that much time. And with ReLU, you might say, oh, but you might zero them all out. Well, if I'm going to zero them all out, then I would end up zeroing them all out afterwards as well. So it wouldn't matter which one I passed on as the max. So I don't think that matters in the slightest. That's just a notational convenience thing. This model's taking forever to compile. I guess the batch normalization takes a while. Hopefully it doesn't slow down everything. Otherwise it might say, not worth it. So, and this model is sort of a combination of a bunch of different ideas, from classic image recognition problems to the comma.ai. the comma AI dataset, as well as what was deepdrive.io, they don't exist anymore. They were AI World, and now they're not anywhere. So I don't know what happened to them. I fell off the bus as far as what they were looking at. They're at Berkeley now, maybe. Okay, they're at Berkeley, I think. I believe this is still the same stuff. Not 100% sure on that. But either way, that's cool. Hopefully all the data is still up on a Google Drive. Otherwise, I've only got the data that I got, and that'd be the other problem. Grab a whole bunch more data. Gosh, this takes forever to compile. There it goes. All right, so I'm paying a price now. Takes a little bit more time. What was like 230 seconds is now legitimately 300 seconds. But that loss is already pretty good. And we'll let it train for just a little bit. Hopefully it'll start doing pretty well. And if it's not, well, then we moan, we complain, we hem and we haw. We say, well, you know, what's the deal here? I don't remember what this stuff was doing. But yeah, so this is just kind of what I wanted to do for my final stream for a long time. As I mentioned, I'm going to be going on sabbatical as far as the channel is concerned. I've covered a lot of things in the past year and a half, and I would like to take a break from that, going through some life changes at the moment. And so I just wanted to do this sort of a classic type of episode where I check out a data set and see what's going on. I should fix this up too. I'm not doing dropout, oh no! That might ruin my validation accuracy. So if you have any comments, any thoughts you want to share about the channel, any things you'd like to see when I come back, or like just different directions to take the channel. I might decide that I've accomplished a whole lot and I don't need to do a whole lot more as far as the channel is concerned, that there's better ways to do that, and that's fine. But I always reserve the right to be like, oh, there's a cool new data set. I absolutely have to check that out. Always a possibility anyway. There we go. That'll be weight regularized. And dropout percent. I don't know, 0.05 or something. Not very many. It's like I can make it a lot bigger. This model just isn't that big. I'm not as worried about the dropout business, because I only got 8 kernels here to begin with. If I'm losing half of them, that's trouble. You know what? I'll put it in the model though. I'll tell you that. Dropout. There we go. Dropout before or after normalization? That's actually an interesting point. That should be after, I think. The idea being, I want it to be scaled based on whatever my outputs are, and then randomly pick half of those to drop out. Whereas if I drop out half of them and then scale it, that might muck with my scaling. Right? I think that's true. You know what, let's not drop out everywhere. Only some places. Like right there. No, right there. Yeah, that's a good place to drop out, I think. 0.01125, so an eighth, we'll say. Because I've got lots of powers of 2, powers of 8 here. Yeah, an eighth of them, which is to say 2 of these. That I could muster. I can handle that. All right, so this model still getting better, and again, this is the cumulative loss, so that looks worse than it is. It's probably not all that bad. I definitely want to let that finish before giving the final sign off of the stream here. So I'm glad we got to do a few more visualizations with this. I'm glad we got to look at this data set again and quickly whip up a new model. And I think this might be the first time I'm using the atom optimizer on this problem. I had it in that other file, but I don't know if I actually used it. I tended to stick with gradient descent because gradient descent I could understand and keep in my head, which is a danger, it's a blessing and a curse. Because then I can understand exactly what's happening, but then I can't do something that's more advanced than I can keep in my memory at one moment. So it is a risk. One has to be willing to be a little bit looser with some of those, with what tools you're willing to use when you're doing these machine learning kind of things. So there's so much of the field that's advancing so fast. It can be difficult to always keep up on exactly what tools are. It's always dangerous to use a tool that you don't inherently understand, though. So like I don't have a strong understanding of what the atom optimizer is, other than it's an adaptive learning rate optimizer. It's like, well, sure, could I use eta delta instead or RMS prop? Yeah, and maybe that's what you want to do, maybe not. All right, this is going to finish up here. Then it'll give us the validation loss, hopefully in the range of 0.1, just to guess. Which would mean it's like, what, 0.13 or something? Yeah, thereabouts. Validation loss, 0.1, just about. And it could almost certainly be improved through additional training. And it probably will be improved through additional training as I futz around with this more and more. Okay. Shouldn't take that long to make these predictions. Only going through a tenth of the dataset. So I guess that should take like 40 seconds actually. Or 30 seconds. Yeah. Well, just 33 seconds, right? There it goes. Okay. Doink. So now here's what I'm going to declare the final model of DanDoesData. The red line saying you're turning this way or that way. And you can still see it diverging from the correct answer a fair amount of the time. But when there's not a whole lot going on, it does the correct thing. Of course, for a self-driving car, you need it to do the correct thing when it is doing something weird, right? That's the one time you want it to do the absolute correct thing. If you're just going straight, like running into of course now when like running into a boat apparently. I'm still never 100% sure whether these lines are pointing the correct direction. Right? I mean, like, are we lifting less here? Gosh, this boat! No, the boat is terrible! Oh my gosh, I hate this boat. Much better, okay. Mostly straight, list a little bit. We just really want to get around this boat. I think that's the problem. Alright, I think I'm going to leave it on this. So I want to thank everyone for coming out. Anyone who's ever watched the show over the past like year and a half, maybe like something like 18 months or 20 months, something like that. Thank you very much. If you ever left a comment, if you've ever sent me an email, anything like that, thank you again for coming out. I hope you found this educational. I know I have. I've gone from only using linear models to do things and being very happy with that to learning all different kinds of pieces of software and new tools and techniques in the machine learning world, especially regarding neural networks and using GPUs with Python to make these work very quickly and capably. So we've got to build a lot of cool models. We got to learn a lot of cool new things. So I just once again wanted to say thank you. And don't forget, stay safe in the data mines. Have a good night, folks.